This is Charles Angel Group presenting Reed's Law from MIS 4478 Tuesday session. Before we go into Reed's Law, let's look at the law before it. Sarnoff's Law. It's attributed to David Sarnoff. Sarnoff's law is a mathematical description from a broadcast mass media age, which was first applied to cinema screens and later to TV. It states that the value of a network grows in proportion to the number of viewers. It's a straight line. The more viewers, the more value the network has. For example, a network with 100 members is 10 times as valuable as a network with 10 members. Followed by Sarnoff's law, we have Metcalfe's law. This law states that the value of the network grows in proportion to the number of nodes on the network. This law offers a better way of measuring the relentless growth of the power of the Internet. It was originally presented to measure the power of communication devices such as fax machines and telephones. For example, a single fax machine is useless. 2 has more utility, just like 2 squared equal to 4. And each one that's added to network increases the value of all nodes on it. The value of every fax machine increases with the number of fax machines in network, because the total number of people with whom each user may send and receive documents increases. The same can be said when apply the law to the Internet. In social networks, the greater number of users with a service, the more valuable the service becomes to the community. David P. Reed introduces us Reed's Law. The law states that the utility of large networks, especially social networks, can scale exponentially with the size of the network. The number of possible subgroups of network participants is 2 power n minus 1, where n is the number of participants. To understand the Reed's Law, we need to understand that the value of a one-to-many networks grows in proportion to n, and the value of a one-to-one network grows in proportion to n squared. However, in a group-forming network with n number of members, the number of possible subgroups those members could form is 2 power n minus 1, which is exponentially like 2 power n. Thus, the value of the network increases exponentially in proportion to 2 power n. This is much more rapid than the previous two laws we were talking about. Sarnoff's law is value grows in proportion to the number of participants. Metcalfe's law is value grows in proportion to the number of possible pair connections. So thus, these group-forming networks tend to dominate the overall value of the whole system. Networks that support the construction of a communicating group create value that scales exponentially with network size. Networks that connect peers for transaction create value that scale as n power 2. However, an individual's attention and money scale only linearly. From this, Reed concludes that because group-forming networks create more value for users than either broadcast or peer networks, they will outperform other forms of network connectivities, both in ability to gain attention and in return on investment for businesses. This is immediately important for businesses that have networks such as supply chains that they wish to expose to the Internet for business agility. In the literature on cooperative and collaborative systems, it is often stated that there is a dramatically increased benefit from the Internet scale of connectivity. Reed has provided mathematical clarity for this observation. Specifically, if we view the Internet in terms of Metcalfe's law, which grows as n power 2, then for group connectivity, while 2 power n is small initially, as n grows, it grows much faster than n power 2. Hence, the dramatically increase in value or benefit. Facebook has seen the effect of Reed's Law happen more rapidly than any other site on the internet. For example, when a person becomes a fan of a Facebook page, that page shows up on the feed of that person's friend, and their friends have the opportunity to become the fan of the page and extend the exposure of that page exponentially. The more connection that a user has, the more value they bring to the Facebook page. The social networks that will win are those that provide the best tool for group forming, which is the ability for users to define and collaborate with groups of other users of their own choosing. Such networks provide the best utility to the user and the best potential value for the organizer. AOL read the effects of Reed's Law in the early days of the internet. eBay did the same when it created and dominated auction-based commerce. Reed's Law explains why Facebook beat MySpace and dominates today's social media. Companies of every stripe should now focus on how to use social media technique to win the battle for user attention in the particular markets and to define against competitors and new entrants. Nowadays, many businesses have their own social network sites like Facebook page and Twitter, as long as they keep these sites updated with new interesting features. The marketing will get done on its own, as each people that like the page or follow, tweet about the company will advertise the company to the people in the network. And if those people like the company, the circle continues and the marketing opportunity increases exponentially. In addition, if companies create networks for users to meet, groups for users to join, they create opportunity to increase the connection of the user and potential increase the value of their site. As opposed from the vast opportunity that could derive from Reed's Law, there are also some limitations to it. First, based on the research on Dunbar's number, there's a suggested cognitive limit on how many people one can maintain stable social relationship with. This number ranges between 100 and 230, commonly used as 150. Numbers larger than this will require more restrictions and rules to keep the relationship stable. Thus, the effect of Reed's Law might be smaller than it potentially claimed to be. In addition, Reed's Law states that each new person on a network doubles its value. So, adding 10 people to the network will increase the value of the network by 1,000 times, as 2 power 10 equal to 1,024. However, if we look at the value of the network realistically, a network with 50,000 10 people can't possibly be worth of 1,000 times as much as a network with 50,000 people. At some point, the number of people on a network is so large that it does not realistically make sense to conclude that the value of the network double by one additional person joining the network. Despite its limitation, Reed's Law fundamental idea on the immense growth of network value based on the number of connections and group formation is true. The effect of the law can be seen in the growth of many social networks, especially Facebook. Thus, if a business can apply Reed's Law and take advantage of those social networks, they could vastly increase the marketability of the company and increase the value of the company enormously. This is our work cited. Thanks for watching.